Hi Year 9, we are moving on to trial and improvement methods to try and find a solution now for maybe a quadratic equation, or you might have a cubic equation. Imagine you were trying to solve this using factorising that we've already seen. You would probably move the 17 across, wouldn't you? Take away 17, you'd have x squared, add 5x, take 17 equals 0. And then you'd get a little bit stuck because you'd be trying to find two numbers tising together to make minus 17 and adding together to make 5, and you can't actually find those numbers. But that doesn't mean this can't be solved. And there are various methods at solving quadratic equations. You've just met factorising, but you will see when you're a little bit older that you can complete the square. I'm going to show you the quadratic formula if we've got time soon. But the method we're going to be using today is called trial and improvement, where we try something and it might not work, so we try something else, and it might be too big or too small, and we try something else. Okay, now normally you're told how accurate you want the answer, so we want it to 1 decimal place. We're also told we want a solution between 2 and 3. So when we're told we want a solution between 2 and 3, we generally go halfway and we will go for 2.5. And then what you're going to be doing is you're going to be trying 2.5 squared, add 5 times 2.5, and we want to see how close or if we're too big or too small compared to that answer. And in fact, it is too big. So then you try something a bit smaller. You could have tried 2.3 or 2.2. We've gone for 2.4 there, so you'll be doing 2.4 squared, add 5 2.4s, and that is also slightly too big. So then you try 2.3, 2.3 squared, add 5 2.3s. It's now slightly too small. So now we know our solution is between 2.3 and 2.4. But we've only got to give our answer to 1 decimal place, but I don't know whether to go for 2.3 or 2.4. And you don't bother checking, oh, well, that one is a bit further away than this answer. What we actually do, we try and prove which is better by now just going halfway between those two possible answers. So we'll try 2.35, 2.35 squared, add 5 2.35s, and we get 17.2725, which is slightly too big. So because that's slightly too big, then we know our solution is now between 2.3 and 2.35. So if you have a look at this, 2.3 was too small, 2.4 was too big, but 2.35 is also too big. So our answer lies between these two. So if the answer lies between these two, anything in that range will round to 2.3. So your solution is 2.3. So remember, we always draw a table. We usually use 3 columns. X, or whatever letter is in the question, value is what you've actually worked out for your equation here, and then you make a decision whether it's too big or too small. So there's a few more for you to have a go at there if you wanted to have a go at those on your own. Look, you're often told where to start, so you'd probably go for 3.5, 3.5 cubed, add 3, 3.5 squared, and see what you get. So I'm not going to do these with you. Here's another one. These are all exam questions. So again, look, you know it's between 5 and 6. You probably go for 5.5 and see what 5.5 cubed add 5 squared is, etc. And that's 5.8. Here's another one. Now you're not told where to start on this one, but you can see I want a number cubed, add 4 times that number, it has to be 100. For example, if you did 3 cubed, but that's only 27, add 4 3s, that's only 12, so that's only 39. If you tried 4 cubed, that's 64, add 4 4s is 16, that's about 80. If you tried 5 cubed, well, 5 cubed is 125, so that's too big. So I know I can hear the answers between 4 and 5, and you set out your work in a table and get something like that. I'm just going to show you a slightly harder one. You won't get this on the exercise that you're doing. I think when I checked them earlier, they are all to 1 decimal place, but you will get some to 2 decimal places for your GCSE. So I'm just going to show you how you would do it. So x cubed add 4x needs to equal 170. You're given a starting point. It's between 5 and 6. Use trial and improvement now, and I want to use 2 decimal places. Show all your working. So this one's a bit harder. So there's my answer, but let me show you how I'd set it out. Okay, so a bigger table I now need because I've got to go to 2 decimal places. So we were told it's between 5 and 6, so look, I've gone for 5.5, too big. I then tried 5.3, too big. 5.2 is too small. So I know that's too small. Well, at least let's see how close we can get. So I tried 5.25, that's too small. Now if I was going to 1 decimal place, I've got my answer now. 5.2 is too small, 5.3 is too big, 5.25 is too small. So I know the answer is between 5.25 and 5.3. So the answer would be 5.3 if it's to 1 decimal place, but I've got to keep going. I need to go to 2 decimal places. So I want to know if the answer is going to be 5.25, 5.26, 5.27, 5.28, 5.29 or 5.30 in fact. So look what I now try. I try 5.28 and that is too small. You've got to remember, by the way, that 5.3 is actually 5.30. So then I try 5.29 and that is too small. So I know the answer is between 5.29 and 5.30 because look, that was too big and 5.29 is too small. So because I want 2 decimal places, I now go halfway between 5.29 and 5.30, which is 5.295, which is also too small. So if you think about it, that means the answer is between 5.295 and 5.30. And anything between 5.295 and 5.30 will in fact round to 5.30 to 2 decimal places. Now do not worry if you didn't quite follow that one, because like I said, I think yours are only to 1 decimal place. Okay, so in your textbooks, remember, use your Caboodle link. I think it was at exercise 11I. Have a go at 1 to 5. This was slightly harder one, 6 to 8 at the end. So each question you are setting it out in a table, X, value, and then whether it's too big or too small. These are only slightly harder, if I remember, because when you try something and it's too big, you actually then go for something even bigger. It will make sense when you have a look at those. Anyway, so have a go at those, and here are the answers when you need them. Okay, thanks.